Hi Year 5, we're on to lesson 14. This is your final lesson on adding and subtracting decimals. In today's lesson, I would really like you to think about moving as quickly as possible onto the extension. Now, I know some of you will find that a bit trickier, but I would prefer you not to do your workbook again, just like yesterday. Do the extensions first and then come back and complete your workbook if you have time. Because the extensions are really pushing the reasoning side of the decimals, and that's actually really important, especially as now you've got a really good understanding of it. It's more about applying that understanding to other situations. So we're going to start off with our own focus. I'm hoping that you haven't looked at it. It's okay if you have, but if you haven't looked at it, this is great, because I just want you to start off by thinking about what questions could you ask or what statements could you make about this. So we've got a picture of a board. It tells us it's rectangular and we've got two measurements. One says 2 meters and one says 0.8 meters. So I want you to start off by thinking about just that. What could you say about it, or what questions could you ask about it? So you're starting off with a bit of brainstorming. So pause the video, have a go at that, and then come back and we'll have a look at it together. Right, okay, so we've simply got our board here and we've obviously got two measurements. It tells us it's rectangular. That's really important, okay? So let's have a think. What sorts of things might we be able to say about our board? Well, first thing is, if I know that it's rectangular, if I've been given this measurement here, hopefully you recognise that you actually also know this measurement here. So I know that this is 0.8 meters long as well, okay? And then the same goes for the longest side. I also know that this is 2 meters long, okay? So that's one thing I could add. Something else I might be able to say is I can say, oh, I wonder if we can bring in, not to do with decimals and adding and subtracting decimals, but also we could actually look at it and say, well, we know we've got some right angles. Look, let's think about it in terms of shapes. So we've got 4 right angles. Don't have to always be thinking along the lines of decimals. We've got some other things we can say. So if you haven't thought about anything else like that, perhaps you can pause the video and think about that before you carry on listening. Okay, carrying along the lines of thinking about properties of shape, you could also say that we've got a line of symmetry. Look, so we're not just thinking about adding and subtracting decimals. We might move on and think about other things. So we've got lines of symmetry. We've got a line down here, and we've got a line across here of symmetry. Now, I'm not doing it very neatly. I should have got a line properly, putting my own dots, but sure you'll do it neater than I am. Okay, could we say anything else? We could say that it is a 2D shape. 2D shape. We could say that this line is perpendicular to this line. So we could use some of that lovely language, perpendicular. Anyway, I'm not going to go on too much about that, but there's some ideas of other things that we might be able to state about this. So let's come back to thinking about our adding and subtracting of our decimals then. Well, we might ask the question, if I need to find out the area of my piece of wood, say I'm trying to figure out the area, this is a table and I'm trying to find out the area of it. I wonder if anyone remembers how we find area. Area is length times width. So can we work that out? Well, some of you might be thinking, oh, we haven't done multiplying decimals, so don't worry. If you're not sure, you really don't have to actually work it out, but it's just thinking along those lines and thinking what we could ask. So I'm not asking you to work it out, but hopefully you realise that area is the length times the width. So to work out the area, we could do that, which I know some of you could do. In fact, I know all of you could do, because what we can do is we can do 2 multiplied by 8, all right, is 16. And then we know that this is 10 times smaller. So we have to take our 16 and we have to divide it. I haven't got a divide sign, so I'm going to just use that for now. Divide it by 10. 1.6 meters. And then hopefully you remember it is squared. And again, I'd have to search to find that squared button. So I'm going to just write squared. Okay, I'm in the way of that, but There we go. Okay. Right, let's come back to thinking again about our decimals then. Maybe you might ask the question, what is this length? Add this length. Or we might say, what is the perimeter? Hopefully you can remember when we're talking about perimeter, we are thinking about the distance around the outside. So if I had to walk around the shape, I would walk along the 2 meters, the 0.8, the 2 meters, and the 0.8. So I'd add those together. And we're going to come in a minute to have a think about how we might work that out, okay? We might say, how much longer is the longest side than the shorter side? So we've got the longest side is 2 meters, and we might say I need to take away 0.8 meters from that to find out how much longer it is. And if we think about that in terms of a bar model as well, let's quickly draw that. So I've got the 2 meter side and the 0.8. This is 2 meters. If this is 0.8, then I need to know what this bit here is. So if I quickly pop just a line in there for now. Okay, what's that bit there is what we're trying to work out. So we're doing 2 take away 0.8. So there's lots of questions that we could ask. We might say, what is 2 of the longest sides added together? 2 add 2. What is the 2 shortest sides added together? That's 0.8, add 0.8. So it's about really, really digging deeper into thinking about those. So I've jumped ahead of myself a little bit here because this one is compare the lengths. So those of you who have looked at your info, because these are the questions that are actually asked, compare the lengths of the 2 sides. Now, if we're comparing them, we want to say, what is the difference between the 2? And in order to do that, we would do 2 minus 0.8. So we're going to have a look at that in a little bit more detail to think about how would we actually do that, because that's a little bit tricky where one is a whole number and one is a decimal. So let's have a look at some ways that you might be able to do that. Okay, here's method 1. What we could do is we could split our 2 into 1 and 1. Okay, so we've got 1 and 1 because that's our 2 whole numbers. So we're going to keep this one as 1. We're not going to do anything to that. So we'll put a little bubble around that to protect it. And then this one here is the one that we're going to use to take 0.8 away. So that one is protected. We don't need to touch it. And this one here, we're saying 1 minus 0.8. So this is thinking about what you did yesterday, where we're thinking about combinations of numbers that go together to make 1. Hopefully, from your work yesterday, you remember that 0.8 plus 0.2 is your number bond that makes 1. So 1 minus 0.8 is 0.2. Now, is the answer 0.2? Or have I made a mistake there? What do I need to do? Yeah, you're right. I have to remember that I had this 1 that I protected. I put it in the bubble and I left it there. And I just took 0.8 from this one here. Okay, so this one has now become 0.2. And I had my 1 here. So my final answer will be 1.2. Because the 0.2 goes with the 1. And let's just quickly look at that. We've got 1.0 and we've got 0.2. And when we add those together, look, the 2 can go on top of that 0. There's nothing to add, so it goes as a 2. And there's nothing to add from this number, so that stays as a 1. So it's 1.2. Okay, let's look at method 2 quickly. The other way that you could do it is you could convert. So rather than saying it's 2 whole, you could convert 2 1s into 20 tenths. And then we know that 0.8 is 8 tenths. So we've actually got 20 tenths take away 8 tenths. Now I've drawn some place value counters here. You could have a go with anything that you've got at home, stones, whatever. Put 20 stones out and each of them is worth 0.1. And then all you're going to do is you're going to take away 8 of them. So let's do it together. 1, 2, 3, 4, 5, 6, 7, 8. Okay, Hopefully you've done that as well. So let's see how many are left. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. What comes after 0.9? 10. Good. So that, well, not 10, sorry, one whole. So that here is not 0.10, remember, it's 1. Okay, and then we've got 0.1, 0.2, so it's 1.2. Okay, 12 tenths. 12 tenths is 1.2. Right, okay. Now you're going to need to use those methods when you come to do your work later, so think very carefully about that. Now let's come back to this perimeter that we talked about. There are 2 methods for finding this as well, finding the perimeter. Let's have a little look at these 2 methods that you could use if you need to find perimeter. Okay, so we're looking at perimeter because it allows us to look at adding and subtracting decimals. In this case, it's adding decimals together. So we know that the perimeter is all the way around the shape. So we know that we need 2 meters, 2 meters, 0.8 meters, and 0.8 meters. So this first method, it chooses the 2 longer lengths and added those together, makes 4 meters, and chooses the 2 shorter lengths, adds those together, and makes 1.6. Now, an easy way of doing it, remember, is going 8 add 8 is 16, but both of them are 10 times smaller, so you need to make it 10 times smaller. Okay, so that's your first one, which makes 5.6 meters, not meters squared, it's meters this time. It's only meters squared if it's area. And then the second way you could do it is you could do the longest side plus the shortest side, which is 2.8, and then find 2 of those. So 2.8 plus 2.8, and we can obviously do that by putting it, oh look, let's get rid of that. Let's do it with our, okay, 2.8 plus 2.8. Okay, 8 add 8 is 16. So I'm going to need to put a 1. I'm going to exchange my 1 for a whole 1. And I've got 6 tenths. And then 2 add 2 is 4, plus the 1 is 5. 5 whole and 6 tenths. And I'll make sure that that's nice and clear. Okay, right. Hopefully you feel okay with that. So you're ready to move on to your guided practice. So the first thing you're going to do is find which 2 numbers give the greatest possible sum. There's that language again for you, sum. You're going to need to convert. Can you do it mentally without using written methods? Can you have a go at doing it mentally? You've got 2 calculations to subtract, and then here you're thinking about calculating the perimeter. You can use either method that you've been shown for this one. So think back to the methods that we just talked about. Choose whichever you think is easiest. And then the final one, calculate the perimeter of a square in which each side has a length of 4.9. Now, remember I said, I don't want you to do your workbook until you've done your extensions. So you're actually going to skip over this, come back to it if you have time. So let's have a quick look at your extensions. Just like yesterday, you've got 3 levels. This is level 1. So you've got some reasoning questions there based on decimals. This is level 2. We've got problem solving questions and then some reasoning. You'll notice I've given you a bit more this time. That's okay. I think you'll be confident with that. And then this is the level 3. So we've got reasoning and we've got problem solving. Sorry, I apologise. I've given you the wrong bit there. So you've got this question and then you've got a different question underneath, but you'll see it on the sheet. Okay, so all the answers are attached. You don't need to do every level. You can if you want to, but you really don't need to. I'd say maths teachers group, you're definitely doing this one. Those of you in pre-skills, you might like to have a go at this, but you might be able to challenge yourself with level 2. And the rest of you should really be doing this or pushing yourself onto the level 3. Okay, I hope it goes really well.